satisfy this. I just thought I introduce myself by just copying my GitHub profile. Yeah, so I'm working with Ruby since 1.8.7 and with Rails since 2.3.2. So I have some of these experiences Terence just talked to us about. It was quite horrible. That's the building we're working in. That is the dancing towers in Reeperbahn 1, so you will see them when we go to the party later. And I work for Exine GmbH, that is a cloud provider. So that's the reason why why I have some experience with Kubernetes there. One short thing before I really start, when you have questions or suggestions, please just feel free to interrupt me anytime for clarification. It could be that I'm sometimes a little too fast. I'm very sorry for that because I'm quite a little nervous. But so please always interrupt me when I'm too fast or when you have some questions. Okay, what I want to talk about is I will firstly start with containers, since Kubernetes is about deploying containers or orchestrating containers. Then I go forward to Kubernetes, and I wanted to do some live programming since I have some problems to reach Kubernetes from here. I just changed this point some earlier, but didn't change it here. So I will show you some examples we just used in our apps. Okay, Docker. Who of you has already experiences with Docker? And so everyone, okay. So I will try to go fast through it. Most of the time you will know about Docker. What is Docker? When Docker is explained, often people show this by differentiating between VMs and containers. So the main difference is that when you run Docker, Docker container, that all these Docker containers don't have the split kernel like in when you have a hypervisor and then VMs who have their own operating system and their own kernel, but they encapsulate binaries and libs, so you get some increment that that really works. Yeah. Okay. When you look a little deeper, it often when you see a Kubernetes deployment, it often is not that easy because you normally then run Kubernetes in some cloud, and then you have KVM, and inside KVM some Kubernetes. And it looks like this, but I come to this back to this a little later to get some of those things clarified a little. So yeah, this is one maybe standard Docker file. Since you all have experience with it, I won't go through it too deep. But the important thing when we have this container in the end, after we did the build, we have some encapsulated, we can put it into our pipelines, do some testing in it, and we know at least when for most of the tests, when we have some automated tests, that this increment should still work later. Of course, there are other tests like doing some audits on NPM audit or bundle audit, or to check your container with, for example, Claire scanner or something like. If you have some security issues later, so there should be some tasks that should be recurrent and come again after later. But the ones about the test, that should always work afterwards. So coming to Kubernetes now, because when we now have this container, we still don't run the app. We can run this on different computers, so we share it and we have some working increment. But yeah, just run this one container on one VM is not really high available. It's not really easy scalable, but you maybe start with some Docker Compose file and so on. And then comes Kubernetes as the orchestration tool that will help you to get several benefits you don't want to care about, like networking and so on. So what is Kubernetes? Kubernetes was an open source project that was started by Google. It's de facto this one standard software for container configuration and automation. And if you know OpenStack, then you could compare OpenStack as kind of for VMs, like as Kubernetes is for containers. Why Kubernetes? Yeah, one big point, of course, when you're already working with containers, then it's a good tool to bring it into production. Kubernetes is quite scalable, so if you have master nodes and two worker nodes and you need more, then you just add another worker node and it's scaled. Yeah? And on the other side, it scales your app. So if you not only want to run one container, but 2, 3, 4, then you just change a little configuration in Kubernetes and it starts your containers and checks that health checks that you have provided still is working and will hold this alive. So it has momentum, and since there still are quite a lot of operators working directly with it, it has still quite much, there's quite a big chance that all the smaller problems it still has that will go away, and this will develop quite further. So if you want to try with it around yourself, there's one quite cool project that's called K3S. If you know that K7S is a short for Kubernetes, like I18N is a short for internationalization, then K3S is very short thing. Yeah, is for Kubernetes it's a single node thing. So it's not HA, but it's nice. It's very easy to install, and it's quite nice to just try around with it. Okay, I wanted to promise to look again into Kubernetes architecture. So what components is existing inside? There is some, for example, etcd, which is a key value store that holds the whole state of Kubernetes. So that is one thing that you want to back up and want to ensure you always have. There is Calico node, for example, as a network for networking. Yeah. So it has several components to just give you the advantage to not have to think about everything, although you still should understand a little about it. So I want to go to the Kubernetes concepts. Kubernetes has several components, and the shortest unit of it are pods. Do you know what pod is? No. Pod is cluster. The minimum of containers you need to just run this app like. So when in many cases it could be one container inside, it's just your app. But when you recognize, since you want in Docker just to have running one process in one container normally, there are sometimes you have this feeling you need another process in this container. Normally, you shouldn't put it into the container, but put it in another container and maybe share some volumes between them. And then you declare in the pod that you always need those two containers, for example. When maybe you want to have some Nginx to serve your static assets or something alike, then this would be a possibility to just have there an Nginx and your Rails server, whatever. Or another example would be when you work with Logstash, maybe you want some Logstash agent or something like, always running with a container to parse logs. This is most of the time the case when you have some app where you can't control the logs. Then you declare that this pod always has the app you want to have there and the Logstash agent which parses your logs. The next unit is the replica set. So when you say you want always to have at least three of these pods running, then you say in the replica set, you declare the replica set to be 3, so for this pod. So and Kubernetes will then care about running all those pods parallel to each other, and when there is some issue that crashes your container and it's not in zombie mode, yeah, but it really is crashed, then Kubernetes will care about restarting it. So you get again the number of containers of pods you just declared in the replica set as replica set. A deployment, that is the thing where you define pods and replica set. So you explain which containers you need there, you explain how many you need there. This is inside of the deployment. So this is the first thing where what you use to configure your Kubernetes. In Kubernetes, you can use YAML or JSON normally to configure your number of containers and replicas inside of a pod inside of this deployment. Then most of the time we need some configuration in our apps. And when we have different environments, we need even different configuration. And you do this inside of config maps. So in config maps, you can describe, you can hold some template for configuration YAMLs or whatever, or you just define some environment variables. And then there is the service declaration. This is very often a little bit confusing that there is a deployment and a service. So whenever you have you describe a deployment and run your pods, the service explains which pods will be opened for this pod. So yeah, since you know already Docker, so it's about publishing pods, but it's not only about that. There is some possibility to define a service for some application that's running outside of Kubernetes. For example, we use Cockroach. Do you know CockroachDB? Yeah. This is key value store, but with a PostgreSQL front end or data. So you can still use Active Record to talk to Cockroach. And the great thing about Cockroach is the horizontal scaling. So you can just run several Cockroach instances that all are master. And yeah, when you have now three different Cockroach masters, you want to do load balancings from inside your app to these Cockroach masters, and this is a possibility to describe it inside of a service and define there the 3 IPs of this 3 different Cockroach instances, and even do some live check, to keep a live check or something if this IP is still reachable, and if it's not, well, because your database node just went down, maybe because of maintenance of the cloud, when there's one availability zone that is just going down, then if you configured this, then Kubernetes will just take care that to remove this one IP, and you only talk to the other 2 still alive instances of Cockroach. Oh, sorry. Okay, then there is an ingress. This is the load balancer of Kubernetes. Oh, sorry. This is the load balancer of the Kubernetes. So there you describe which domains should go to which containers, or to which pods in the end. Every pod gets one descriptive name from Kubernetes. So whatever many instances you have, you just describe in the ingress this one pod name, and the whole load balancing will be done kind of from Kubernetes. Another service most of the time in Kubernetes is offered is the cert manager. So this can take care about Let's Encrypt, for example. And a quite important tool, or one tool that you can use for deployment. There are other possibilities, but Helm just got very strong as Helm. So Helm is the package manager of Kubernetes, and it offers a template descriptive language to define all the config maps and the deployments and so on inside of templates. So you can use one template for different environments and just add some secret variables or others for this special environments then. Okay, and last thing that Kubernetes helps you with is it gives you the opportunity of a cron job. For example, you want to, when there is a possibility to, for example, have a database inside of your Kubernetes. Of course, this is very strongly discussed if you should have this, but of course, there is the possibility to have the database with a persistent volume inside. And maybe you want to do some dumps, for example, in some time. Then you can define a cron job that starts your database container and does a dump and pushes it to some S3 or something alike. This cron job always creates a job, and you can define inside of the cron job how many jobs you will still hold in memory, so you can check the logs if there's something happens, for example. Okay. Another thing of Kubernetes is namespaces. So if you have several projects and you want to separate them, you can do this with namespaces. And when you have namespaces, you maybe want to have service accounts that have only access to one of these namespaces, for example. But this can be defined quite more granular. Okay. As I said, I wanted to do some live coding here. I don't know if I can't reach it because of some wrong setting of my firewall currently in OpenStack, or if it is because maybe the ports are blocked from here. I don't know. Ports are blocked. Ah, okay. Okay, then I need to figure out something which, if anyone is interested to do a workshop tomorrow, because when the ports are blocked, then we can't access the Kubernetes unless I figure something else. But yeah, I just show you some of the Helm templates we're using. So just to see if you remember, what would be the first thing we define when we want to define what a pod is? First thing where we define a pod was the deployment. So there is a deployment YAML like this. It's of course very big since it's a real application. You define, as I mentioned, replicas, but you can do this in some other variables that you just merge into each other by Helm. So you define replicas, you define some other data, you define the containers. You can define an init container, for example, if you want to do a RegDB migrate. Yeah? Zoom, yeah, sorry, of course. Yeah. Sorry, I should. Okay. You can have, for example, init containers that are just run once, so you don't have to do RegDB migrate inside of a container, for example. Then you define containers, for example, like here's something with already working with an Nginx and with some grok. And you define volumes inside here. So when you use some YAML template files to configure your app, or you use some environment variables, of course, and then you define the environment variables. I think there was a Rails environment, for example, as I'm sure there was. Yeah, right. This is how you can define the, define some environment variables per container. The next thing you needed was like the config map, where you can describe how your templates maybe look like, your configurations. And as I explained, there can be some. There is a service, and in the service you define which part you open. And yeah. Sorry. I thought that would be zoomed all in. It's not. Okay. So, and in an ingress, you can directly define that you want to use some cert manager, and you can use little logic with if then else if you need it. Okay. Are any questions left? Yeah.
What, if any, is Kubernetes in some way comparable to Docker Compose, or is that like completely different things?
I wouldn't say it's completely different, but of course Kubernetes does much more than Docker Compose. In Docker Compose, you define which containers are talking to each other and so on. But you don't have them on several different nodes, for example. You don't, you run everything on one machine or one VM or something like that. And this is totally different in Kubernetes, since there you have several Kubernetes nodes, and there and you have this keep alive that Docker Compose doesn't have too, right? I don't use Docker Compose for some time, so I'm not quite sure, but I think there was not no health check, and here you have something like this. You have this, these additional things like these services to the outside if you need something like that. You have the managing of Let's Encrypt certificates if you need that. That's nothing that you get from Docker Compose.
So you don't use Docker Compose
no.
At the same time?
No. Yeah?
Can you just say that Docker Compose is more like a combination of pods and service?
Yeah, that sounds. Of course, service is a little more.
Kubernetes, so you need Docker Compose because Kubernetes can do it for you.
Yeah.
Yeah, it kind of sounds like it's one level lower or one leaf of the tree.
Yeah. It's just part of it.
Yeah. There was, yeah?
If you use this, do you actually, is there any scaffolding involved? I think if I look at those 7 YAML files, or is this, you have to go through the pain like one time and afterwards it's copy and pasting and replacing certain variables?
We built our GEM for it to generate it for us, but there was no scaffolding.
So it's, one has to go through the pain for the first time.
Yeah. And there of course, several things we don't maybe use that others would need, or on the other hand, we need some additions like we need to be able to declare on ingress to forward port 53 to our DNS service inside, and something like this. There's, of course, several things that are so specific for everyone. I don't think that there is a easy scaffolding for it. Yeah? Yeah.
If you do like Ansible, for example, which is something completely different, but they have like, let's say, like a complete Ansible playbook, if you have seen it, like it's on GitHub, and then you can see, okay, this is all the things I can do, even though you can't run it, because it just describes everything. Is there something for Kubernetes in that way, or do I have to go through the whole configuration, documentation to find everything, every little nook and cranny out there?
Thing is that something like Ingress, for example, is not automatically inside of Kubernetes. So you have to deploy an inverse, for example. And there are some different inverses, like an inverse, an Nginx inverse, an HA proxy inverse, and so on. So there's quite a lot to go through it to get to the point where we just have everything. We are using Ansible to deploy Kubernetes itself, but yeah. Yeah.
I have two questions. First of them, what about great feature load balancer?
Sorry, did you?
Load balancer. Load balancer.
Please repeat the
Load balancer.
What?
Load balancer. The inverse is a load balancer, yeah. Or what was the question? Load balancer?
Load balancer.
Load balancer?
Yeah.
Yeah. The inverse is a load balancer. Like it's an engine.
And
Yeah.
do you think that it's a great feature for this orchestrator?
Why the inverse is a great feature?
I think why you I know that Kubernetes have load balancer feature, and for your opinion, why it is great feature, and do you use them in production?
Yeah, we are using it. As I just have opened this inverse YAML file, and we are using it together with a cert manager that cares about all this stuff to provision it with the certificates and so on.
And for your opinion, for what feature do you like this orchestrator? And as the features, what do you like?
When you are through it once, then you get very easy, very fast. All your apps quite easily deployed, and then. But the problem is, of course, to go through all the stuff once. Yeah. So the first step is just a big step, and after that we have all our apps very easily deployed in our system, in our ecosystem.
Last question is, I see evolution of Kubernetes, and at the first person we have great product, but this time this orchestrator be complicated, maybe machine. What about your opinion?
Kubernetes is a complicated machine. What's the question?
Like many features, and this is hard to study or manage them. I think. So, and for your opinion, what about?
To run Kubernetes yourself, this is quite a lot of stuff. We have so many Ansible scripts and heat templates to automate to run this Kubernetes. Now we are at the point where we have a new Kubernetes cluster in 10 minutes, yeah. But it was several steps to get to this point. So yes, it's a complicated machine to have your own Kubernetes.
I think we are out of time for more. Well, maybe the last one.
Yeah.
I was wondering if you run one-time tasks like migrations, is this part of your Kubernetes orchestration, or do you do it outside of the Kubernetes orchestration, or how do you?
You here's one example in our deployment. So there are containers, and you can have init containers. This is only running once, and this is just doing the regdb migrate stuff. And this is running once at the beginning from a new deployment. So whenever we update our containers, then firstly this init container is running, doing the one-time task, and afterwards there's a rolling change of switch to the new versions of the other containers. Okay. Thank you very much.